Billions and soon trillions in value will be created in the autonomy economy. By the time a trend becomes consensus, the alpha is already gone. The gap between uncovering signals and reading headlines is widening fast. When it's a headline, it's no longer a signal. Enter Autonomy AI. We decode signals before they move markets, giving you conviction in the autonomy economy. Autonomy AI. Your models, our intelligence. Visit AUTNMY.ai.
Angus, I gotta let you in on a little secret here. You were the only guest where I get at least an email or a DM every week asking when you're going to come back on. So thanks for coming back on. You're highly in demand. You were back last on in February 2025. We're not going to let that much time pass, but what has changed in the LiDAR industry since you came last on in 2025 in February to today?
Man, well, first, thanks for having me back. This is always a fun conversation. And a lot has happened internally at Ouster, and especially in the last couple of weeks. Actually, since the beginning of the year at Ouster with acquisitions and big product releases. But the LiDAR industry generally, I mean, it's a continual thinning out of the industry. And I'm always amazed how long it takes for a new technology industry to shake out. Like, I think back to 2015 when we founded Ouster, there were over 100 LiDAR startups for the first, basically from 2015 through 2020, there were over 100 startups in this space, and the thinning out takes decades. And so, yeah, we saw a couple companies really fall by the wayside, even declare bankruptcy through last year, and their assets being acquired, and there's still. I always wonder to the average person trying to make sense of this space, if it's possible for the average person to make sense of this space. Like, I have it kept in my head, kind of watching the ins and outs of the industry over the last decade, but it's a convoluted set of companies that have very good marketing. And ultimately, I mean, Ouster has definitely separated itself in the pack in the last 5 years, probably since going public. But yeah, there's still a bunch of competitors making noise every single earnings cycle. So it's a fun space.
Marketing will only take you so far. It comes down to the quality of the product. Has that been one of the defining aspects that allowed Ouster to grow and prosper as a public company?
Exactly. So this is something I say internally is you will never trick someone into buying a multi-$1,000 LiDAR sensor or a LiDAR sensor of any kind, really, that's in a safety critical application. You will never market them into buying a product. LiDAR is too critical to these robotic systems. It's too much a part of the safety scope. There's too much liability. And the problems we're trying to solve are far too hard to ever trick anyone into buying your product. And we understood that very early on. We got immense feedback that was, negative, critical in our early products that we released all the way back in 2018. And it was painful to hear at the time, but we, instead of kind of just giving up at that point or refusing to listen to customer feedback, we iterated and we iterated and we iterated and we improved our products. And that was kind of the whole idea of the company, after all, was digital products. You can iterate them, you can improve them over time. And here we are, REV8, our 8th iteration of our products. And these are the best LiDAR sensors you can buy in the world, bar none.
And their color. I want to point that out, their color. How did you cross that line to make them color?
Yeah, let's talk REV8. So REV8, we haven't released a product at Ouster on the hardware side for 3 straight years. The last time we released products was the REV7 product line, which we released in early 2023. And so internally, we have not just been sitting around. Ouster works really hard, and we've been exclusively focused on this one product release, REV8 with native color. And in many ways, it's not just a 3-year journey. It's actually a 10-year journey for me and my co-founder, Mark. We actually, in our original pitch decks, outlined the goal of building native color LiDAR. So this goes back a decade. We had this vision that the holy grail robotic sensor would have color and depth all coming out of one device, perfectly matched, synchronized, and seamless to the user. I mean, it just makes sense. Like if you think about what a robot, like, what a robot needs to describe the world around it, it's obviously a combination of color and depth. And so, LiDAR, we started with LiDAR because that's really the critical enabling technology for so many safety critical robotics, but we always wanted to add color. We actually had multiple generations of our silicon, including REV7, where the silicon itself had color sensing in the silicon, but we just couldn't quite get the right combination of performance and capability into REV7 for it to be worth shipping. And so we waited and we made it better, and we made this native color sensing better and better. And now REV8 is the first time that, any LiDAR in the world has this native color technology. So we're going to get into it. There's a lot of details here, but this was not an afterthought. This was like a 10-year vision for me and my co-founder, Mark. And it feels really good to finally have it out and see the incredible reaction for roboticists that kind of just get it. They just kind of see that this is the obvious path forward.
10 years ago, what did you see that made you and Mark say, okay, color's the path forward?
We pride ourselves on the one hand of really understanding our customer applications. And so, I spend a lot of my time programming robotics, talking to customers, thought about getting a computer vision degree after my bachelor's degree. So I have a core interest in computer perception. And, I had a lot of fun in the early 2010s following the Kinect. There's this community of people roboticists built around the Kinect sensor. And the Kinect was this Microsoft, like this toy basically for the Microsoft Xbox. That was one of the first widely available, decent quality RGBD or color and depth consumer depth cameras. And it was so cool. It just seemed obvious that if you could pack that kind of colorized point cloud capability into a device with the raw performance and all weather, outdoor, long range sensing of a LiDAR, that you'd have something obviously better and more useful for the customers, for the robotics community. So I would say actually that the Kinect journey that I watched like happening online, and there were other things. Willow Garage was using a lot of RGBD back in the day. There was Project Tango at Google. These were all really short. They were groups using really short range RGBD depth sensors that were colorized, but they weren't LiDARs. They weren't the kind of high performance devices you need to make modern physical AI safety critical robotics. So I don't know, we brought that kind of context to the plate when we set out this vision 10 years ago for Ouster to build native color LiDAR.
Kinect to me was one of those moments. I played with Kinect, and to the Microsoft team, they built that really great jet ski game. We go, and you move your hands and you move the jet skis. But I didn't really play the roboticist then. I was advising a gentleman in media. He had a startup, and his second or third one after a few exits. And when you can move your hand this way, this way, this way for controlling the screen from a user experience standpoint to get the news that you wanted. It just seems like that Kinect, there was a lot underneath that technology that one inspired you to go down the rabbit hole and inspired me to go down this media hole. Do you look back and say, okay, that's one of those critical moments in engineering history, says, okay, that led to a variety of sub-industries?
Yes and no. There was so much promise for the Kinect and that first wave of depth sensors. Leap motion was another one, not colorized sensing, but 3D sensing and basically human computer interfaces that were more natural. And the promise or the reality really didn't quite live up to the promise. From 2010 through 2015, the Kinect was canceled and turned into more of an OEM device. And so, yeah, Leap Motion kind of, I think, failed as a company, ultimately just didn't have the right product market fit. So it was a first wave that showed what might be possible in robotics, but things just weren't quite, stars weren't aligned. The software wasn't good enough. The hardware definitely wasn't good enough for all the applications that Ouster serves. So the challenge is, it's not just about making native color point clouds. It's about making them in a device as performant as a LiDAR, as rugged as a LiDAR, as without caveat as an Ouster LiDAR today, and also now functionally safe. So that's the other headline that, in our REV8 announcement, it didn't get a lot of airtime in our release video, but all of our REV8 products, they're not just native color devices, they're functionally safe devices. They're engineered from the ground up to be a device that you can risk your life on. And that, when you ask, like, what took 3 years to get a product out at Ouster, it's a combination of native color and functional safety, guaranteeing to our customers that this is a product that will not fail, or if it does fail, we'll let you know within 100 milliseconds so that the robot can emergency stop and keep you all safe. So, we've taken that really seriously, and putting the combination of those two things into a device, basically you need all of these things to align to make practical physical AI robotics scale and deliver on that promise that, the Connect potentially started in 2010.
Started, I'll say, ideas in heads. As you said, the technology didn't mature, but it obviously seeded a lot of ideas. And your technology, your ISO 21434 standard compliance, you have that as well. That's a big deal.
It's a huge deal. So the entire, this ASIL-B, SIL2, PLD, the effort required, I don't think that the average person really understands. If you haven't been an engineer in the thick of developing functionally safe devices, you really don't have appreciation for the level of scrutiny, detail, and effort that goes into this. The engineering in the Ouster REV8 LiDARs is much more akin to the engineering in a rocket that takes astronauts into space than it is into a consumer device like a Connect or a Connect or a security camera or something like that. So the orders of magnitude difference in effort, probably 1,000 times harder to get a product out that is functionally safe, because the core idea is we have to be able to sell every last sensor that comes off our line needs to be guaranteed to a standard of quality and reliability and self-diagnosis and performance that's way beyond just a warranty, a normal warranty. If we had a 1% warranty rate, that's a very good warranty rate for a product. 1% returns because something just isn't quite right about the product. That's nowhere near good enough for a functionally safe device. You can't have 1% of your products out of spec and telling a customer that's using these in a safety critical application the wrong thing. And so we completely shifted the perspective of the entire engineering team as we design these REV8 products to a world where we were all thinking, well, we need to be able to trust our own lives on the product that we're designing. We need to, before we prove this to anyone else, we need to prove this to ourselves, then prove this to TÜV-SÜD, our safety assessor, and obviously not just prove so that we can get the certifications from a third-party assessor, and then we can go out and sell these products in a certified way to our customers. So every last detail, every last component, every last line of code has been scrutinized, tested, verified, and then ensured continues to fall into spec as we produce these products at scale.
That's the engineering technical side of the equation. But the other equation that in some cases matters more is the brand. It's the Ouster brand. When you stamp that brand on that LiDAR and you ship it out the door, if there's an issue or something fails, that's not good. You can have the world's greatest engineering, but it comes down to the brand. It seems to me what you described is that you want to build the world's best LiDAR and you stand behind your brand. That's what it says to me.
Exactly. So once you cross this threshold in safety critical LiDAR, the reputation of the company is as important as anything. You really have to prove this to your customer base, though. So this is Ouster's first foray into functionally safe devices. And as a result, one of the reasons you have a third-party assessor is because you have no reputation. We have no reputation and brand for shipping these types of devices. And there's no way to avoid the hard work of building this reputation over time. It's, again, why we took 3 years to develop these products. Having a misstep out of the gate and not having a high quality device, and any question in a customer's minds of whether this adheres to the absolute rigor of the functional safety standards means that we won't be successful in these markets. The whole point of a customer buying a functionally safe device is so that they can put complete trust, single source of trust into these LiDAR sensors. In the same way that you and I buy a car and we put complete trust into the brakes. The brakes are a single redundant system that just cannot fail and is an ASIL D system. In fact, it's a functionally safe system in your cars. And if your brakes ever fail, which they don't, but it really calls into question your trust for those kinds of, that system. So it just can't happen. The same thing, seeping doubt cannot be something that we sow with our customer base. And so again, every last detail has been scrutinized in these devices, down to, measuring every voltage rail, every transistor on the silicon, for instance, has to be doubly redundant checked. So one of the core concepts actually of functional safe devices is redundant and self-checking. One of the two, either redundancy in the systems or so that you get checking through redundancy of basically having two things do the same thing and comparing the result internally. So you can do fault checking, or self-testing the components in between real measurements or real work that you're doing as a LiDAR. You run little self-diagnostics. And so that goes all the way down to the custom L4 and L4 Max silicon chips that we've developed. The actual transistors on that chip need to be tested and self-checked between every LiDAR measurement. Or in many cases, we have redundant transistors on the chip so that there are two different systems doing the exact same work on the silicon so that we can check for faults. And scenarios that we ask ourselves about are like, what happens if a neutrino or a gamma ray from space comes and flips a bit in the ASIC? And well, what do? You can't have this LiDAR output unsafe data. So you need to have redundant transistors so that gamma ray only hits the one transistor, flips the one, and then the other redundant transistor gives you the fault checking, and you have this diagnostic that you can send to the customer. So this gets really detailed. I could nerd out all day on it, and I'm happy to go deeper, but it's really incredible what companies that build functionally safe devices have done to meet that bar.
It's a very high bar to meet. I'll give you credit from a strategy standpoint, from the TÜV SÜD standpoint. That potentially opens the EU market up because a lot of the EU regulations are benchmarked to TÜV SÜD. You mentioned the silicon. So you have your own custom silicon. Is one of the reasons that you decided to build your own custom silicon was to meet let's call it the Ouster safety bar? Was that one of the key reasons why you decided to do that?
The silicon development at Ouster is so core to everything we do. I mean, the answer is yes, absolutely. One of the reasons we do custom silicon is because then we can be at the forefront of this functional safe technology. But it's the core strategy, the founding strategy of Ouster was to build the first digital LiDARs. Silicon eats industries is what we said, I think, in our original pitch deck. Like any industry where silicon becomes the major technology that drives the underlying product performance and economics is absolutely dominated by silicon. And I mean, look at cameras. That's the best example. An optical sensor used to be film and analog, thousands of components, and digital CMOS cameras completely exploded the market. Didn't just capture the professional and prosumer market, dominated and expanded what cameras are even used for. Fundamentally changed where cameras go. And that was all a CMOS silicon technology that made that happen. So silicon eats industries, GPS receivers, even silicon oscillators is something that's happened in the last 5 years. And so that was Ouster's core thesis. And it allows us to iterate and improve the performance. It allowed us to put native color on the silicon. We never would have gotten to native color without doing our own silicon designs. And it also gave us the path to functionally safe devices. And there are few free lunches in the world of hardware development, but in a sense, silicon gives you a free lunch to pack more capability, more performance, more features, more safety onto the same silicon die area each and every year because of the amazing, march of improvement in the underlying transistor technologies that we have access to.
To me, you control your own destiny when you control the silicon because you can enhance performance, you can build the color in it, you can put the safety in it. When did Ouster first develop and commercialize your own silicon?
This was from the very start. We knew we were going to do our own custom silicon. So this goes back to, it's hard for the average person to read about the LiDAR industry and make sense of who's telling the truth and who's embellishing. At this point, every LiDAR company says that they do some sort of semiconductor development. And Ouster, and so Ouster looks like just one of the mix. But the difference is Ouster, we founded the company on silicon design. Our very first product we released in 2018 was soup to nuts, like an in-house silicon design. And we shipped a fully custom piece of silicon that was the L1 chip back in 2018 in our very first product. Now we're on our 4th generation architecture. But we learned the hard way to get to even that first 2018 product. We did 3 different tape outs that were test chips from 2015 to 2018 to get the underlying silicon architecture right. And that was a very, very difficult learning process. There's no way to learn other than by fire and make some mistakes. And so we've actually done 8 tape outs, 8 unique architectural tape outs at Ouster over our 10-year history. And we've gotten really good at silicon design. We have an in-house silicon design team, and 4 major architectures that we've shipped to our customers: L1, L2, L3, L4, and L4 Max, actually. This is the first generation where we've introduced 2 chips into the architecture, the L4 and the L4 Max. So, we're doing silicon design and shipping at scale, and our silicon is much more complex than I think a lot of the other competitors in the space. It's not just a little sliver of silicon that's doing photosensing. We have 40 gigamax of digital signal processing on the chip, huge banks of memory and SRAM, 20 gigabit per second data off the chip. Like, these are incredible devices. Big silicon area that is the core kind of driving force of all the performance and all the safety and all the unit economics of our LiDARs.
If you compare Ouster to Apple, well, this is my opinion as a consumer of Apple. One of Apple's great advantages are their M chips. They're phenomenal. They're fast, they're reliable. And if you go look at public data, you can't buy a Mac Mini today because of the demand for the chips to run agents. And that is a huge competitive advantage to Apple. Do you feel, in your opinion, from Ouster, that your custom LiDAR is your M chip, your huge advantage in the LiDAR market?
Absolutely. I mean, the dynamics are in every market. The market is different, but the reality is you have competitors. And what tools are you going to put into your toolbox to keep ahead of all your competitors? There's no better tool than an in-house silicon design team that's competent and can deliver year in and year out. Because there's no other hardware technology like silicon that has an exponential improvement curve. Everything else in hardware is just staunchly in a linear improvement curve. I mean, look at battery technology. Batteries improve 5% per year. It's an amazing technology, but it's 5% per year. And optics, same thing, 5% a year improvement in coatings or numeric aperture and things like that. But silicon doubles in performance every year or 2 years, even today, especially with the nodes that we're operating with. So it's a tool in our toolbox that's a huge competitive advantage versus the rest of the industry. You have to almost put blind faith in the fact that as a company, you're going to continue to invest in new silicon each and every year. This just never stops. And if you step back and look at what that's done for a company like Ouster over a course of 10 years of chip tape outs, eight chips, 4 architectures, it's night and day difference between the products that we shipped in 2018 and the products we have today. And if you look at that at a company like NVIDIA over the course of 30 years, I mean, Jensen Huang has said that he put blind faith in just continuing to tape out more and more impressive chips, packing more capability into their GPUs, to the point that I think in the late 90s, some of their customers were telling them they don't need more capability in their GPUs, and he ignored them and said, I'm sure once you get your hands on it, you will. So that, compounded over 30 years, you get a company like NVIDIA.
And you go back, I remember this. I was a video gamer and they were competing against RTX. This is when Doom and Duke Nukem and all those first shooter games were there, and we always wanted the new graphics and we were building them. But the thing about NVIDIA is they never stopped building. And Jensen never said, okay, I'm going to rest on my laurels and we're going to have this. They kept building and building and building. And look where they are today, one of the world's most valuable companies. And it's a clear denominator, no matter what side of the aisle you're on, is that silicon unlocks greatness. It's powering the global economy. And since the new LiDARs are color, what type of perception are you getting? What type of depth? And I read in the press release that you had a relationship with Fujifilm, and I got all excited about that because they make really great color. What type of color and perception are we getting?
So this has been a really interesting learning process for Ouster internally. Is shipping native color was not an afterthought. I mean, we had to go partner with amazing companies like Fujifilm and gain access to their color science that they've developed over decades, starting in film and moving into to digital photography. We partnered with DxOMark, a world leader in camera testing and calibration, so that we, brought rigor into the testing of our native color technology. This has been a journey to build this core competency at Ouster. I've gotten the question again and again from customers, well, how do you know how to build a camera? And this is going back years as we were, sharing some of the details on the REV8 roadmap confidentially with customers. And the answer was that we learned through hard work and through partnering with the world's best companies. So, it's interesting because LiDAR measures the truth of the world. When you shoot a ray out at an object and time how long it takes back to measure the distance, there's only one true answer to the distance to all objects in the world. And Ouster's goal is to go measure that truth. And so there's a level of rigor that we can apply to testing and validating our products that's very straightforward in a sense. Now, it takes a ton of engineering talent to actually go do that at scale. But there's truth, and we're measuring it. When it comes to color is an interesting combination of truth in the spectrum. There's a true spectral response from everything in the world that dictates its color. But actually, there's a layer of human perception, which is more subjective, that dictates what a good camera is from a bad camera. And that's a common human eyes, the rods and cones in your eyes, the optics of your pupil, in combination with your visual cortex, actually dictates what makes a good camera. And good cameras are much more cameras that replicate the human perceptual system rather than cameras that just purely measure spectrum. Now, we decide we're going to give customers the best of both worlds. So our native color technology is one of the best just pure spectral cameras measuring the truth of the spectrum in the environment, that you can buy. And but we also spent the time working with Fujifilm and DxOMark to add a layer, an optional layer, but a layer that we're giving our customers that massages color to match the human perceptual system. And so that's been a journey, but it requires a huge amount of detail and understanding. And this is where the term color science really comes into play, and Fujifilm's color science. But every camera company markets their color science, which is the process of taking raw measurements and making them adhere to the human perceptual output, so that when a normal person looks at a photograph, they say, yes, that replicates what I actually see in the real world, versus it being something that, look shifted in color or something like that.
One of my first job when I was like a kid, I worked in a camera store, and so we were a Kodak store. But don't tell anybody, we still use Fuji machines. I wasn't the owner, but we got to learn with it and play with the different chemicals in the different films. Fuji, they had the Velvia, which would shoot at ISO 50, and then at the Fuji 100. And it was really interesting when you would shoot the Fuji Velvia, the slides at 50, the amount of vividness that you would get when you would shoot the 100, or if you would go shoot Kodak, I'm going to go way back, had a portrait and a Velveeta film, and they shot it at 160 and 400. And you would see different variations in the color of how it would perceive the world. Different applications were used for different reasons. Was the goal when you were working with Fuji, say, okay, the vivid stuff is great if you want to have a photograph and put it on your wall, but we need actual reality of what's being seen? Was that one of the things when you work with a color science team that you were trying to achieve?
Absolutely. So Fujifilm has done a great job of building color filter technology that doesn't embellish the data. It gives you accuracy. And then there are ways to then take that accurate data that and further massage it into a format that is useful for ingesting by a machine. And so that's more Ouster's job, is to take great raw measurements that are actually more dictated by the Fujifilm color science and the color filter technology that they've developed. And then with digital signal processing or image signal processing, further massage that data with computational imaging into the final output for customers. And so things that you have to deal with in that process are high dynamic range, right? Like the human eyes and most cameras today cannot deal with the deepest shadows in the same scene as bright lights from a stoplight, or let alone the sun shining right into a camera. And how do you make sense of that dynamic range and make that well, first of all, have the hardware that can measure dynamic range to that level, and second of all, then represent it to a customer in a way that's useful for a machine to interpret. So we spent a huge amount of time on things like we have best in class, or I wouldn't say best in class, but there's no other native LiDAR out there. But when you compare our native LiDAR, our native color LiDAR output to a normal camera, we are at the top end in terms of color accuracy, bit depth. 48-bit color depth that's like cinema camera quality bit depth. Dynamic range, 116 dB of dynamic range, and then 1 lux all the way to 20 million lux sensing capability. So that's a huge range of luminosity that we're able to measure with our LiDAR. So native color in Ouster LiDARs is not just a tack-on or bolt-on feature that's a nice to have. It's pound for pound an exceptional camera in its own right. And you compare it to a modern automotive camera, and it's as good or better in all the ways that matter for a camera in that domain. So, yeah, a lot has gone into native color for sure.
Which unlocks a lot of value, a lot of applications. In theory, from say automotive or machine physical AI applications, could you see your color LiDARs potentially replacing camera?
Certainly, there are many cases where customers don't need a camera anymore. I mean, if you've seen the release imagery from our marketing release last week, I mean, it's most people that have seen the video and that aren't steeped in the LiDAR space and are non-technical have just asked me, okay, I see that's the camera, but, and they basically confuse the LiDAR output as a camera output. And I've had to explain time and again to like all my relatives, no, what you're seeing is the LiDAR generating all this RGB imagery. It's not a camera that we used as marketing material separately. So, so yes, in a lot of cases, we're just going to have customers that can simplify their systems around native color LiDAR. And if you ask just like, where is the LiDAR industry going? I think universal adoption of native color LiDAR is the route forward. It makes no sense to be operating in this like black and white world that we have been for the entire history of LiDAR. Like once you see colorized point clouds and you get your hands on them, and we've actually released a large number of real data sets that you can just go download. So we're putting the proof in the data for our customers to go test out day one. But once you get your hands on that, there's just no going back. Every application has some level of context and information in the color data itself. In agriculture, you really want to know where your plants are versus everything else. The color green is a very important input to machine learning algorithms, turns out, versus dirt. Brown versus green versus the sky versus most objects in the field are going to be a different color than the environment that they're in. And so, or the canonical examples that we provided in our marketing materials, stoplights. With every LiDAR that's ever been made could not sense the state of a stoplight. It can detect that the stoplight is there and located in 3D space perfectly, but you don't know the state of the stoplight. So you can't build historically a robot with just LiDAR sensors that can navigate a surface street. And now you can. Native color gives you the chance and the opportunity to build a unified sensor around just native color LiDAR for the very first time with no other LiDAR or no other sensor needed. Now, does that mean that every customer is going to rip out all the cameras in the system and just use native color LiDAR? No, because there are great uses for cameras still, for really high resolution sensing, reading text on a sign that maybe the REV8 sensors still can't do. But there are plenty of applications that are going full just REV8 native color LiDAR for sure.
The ag's interesting. We've covered ag here a lot, and that you're starting to see automation, autonomy in ag accelerate. Now you're putting color LiDAR into the mix. Do you see color LiDAR acting as an accelerant for the adoption of physical AI?
I really do. I think that this is a game-changing, kind of paradigm-shifting moment for safe, flexible, capable physical AI. Because again, we're combining two paradigm-shifting capabilities into these systems. It's functionally safe, and it's a native color LiDAR. And you really need the combination of those two to make physical AI a reality in the real world. And Ouster, I've always prided myself on building the real, not the prototype hardware, but the real production grade ruggedized hardware that customers need to get their products out in the field. Ouster solves the hard problems so our customers don't have to, at least when it comes to sensing and perception. And so we've done that in droves with REV8. We're taking a huge amount of the effort and the difficulty of fielding physical AI systems by making rugged, functionally safe, colorized systems. So definitely, I think this is going to be the wave of technology, or the technology that powers this next wave of actually deployed physical AI.
It's going to be fascinating to watch what your customers use the REV8s for to deploy. And it's not just color LiDAR that's keeping you busy. In February, you acquired StereoLabs. What's that going to unlock for the company?
Yeah, so this is the beauty actually of the StereoLabs acquisition. StereoLabs is an incredible team that's been building world-class stereo cameras for over a decade, based in Paris, incredibly passionate. And guess what the output of stereo cameras are? It's colorized point clouds. It's native color point clouds. So we announced to much fanfare that when we acquired StereoLabs, we would build unified sensing and perception. Well, what's the most important thing to unify at the very start? It's the data that's coming out of our devices that we sell to customers. And that means colorized point clouds, native color point clouds. So we rapidly closed a gap in about 3 months. From acquiring StereoLabs to announcing REV8, we now sell unified sensing. Every product that we sell can give you colorized point clouds. And that gives a path for software engineers to write unified algorithms that can take advantage of the presence of both of those sensing modalities at all times, right? Like the only way you get convenience and unlock new capability is if you have guarantees on the type of data you have access to at all times. And so, the vision that I have for the company, or the combined companies, is that, customers can pick and choose off this smorgasbord of sensor products that we sell, stereo cameras, mono cameras with neural depth, and REV8 colorized LiDARs, and fuse them all in software seamlessly into one colorized point cloud that's a unified way of dealing with this data and allows for a really high performance path forward for physical AI software. And so this is pretty obvious to a certain set of customers that have immediately reached out and been like, oh, I get it now. Colorized point clouds is the holy grail of robotic engineers, sensory input. And now Ouster offers that across our entire product lineup, whether it's the StereoLabs products or the REV8s.
Is Ouster then becoming the sensing company for the physical AI economy?
That's the vision. Yeah. I mean, someone needs to do it. Some company needs to provide the foundational sensing and perception of safe physical AI. This isn't just about getting prototypes out. It's about building robust, safe systems at scale. And it's what NVIDIA has done for the compute side. Someone had to, this doesn't just happen through like random diffusion of ideas through the economy. Companies have to come out with a vision and build things that really work in the real world. And so our vision is to be the sensing and perception foundational layer for all of this robotics and physical AI work. And I think we're well on that path, right? We are a leading provider of both the camera and the LiDAR technology already. And the recent product announcements, actually both from StereoLabs and Ouster, are just catapulting us even further ahead of our competitors.
Yeah, because the best part is you're making, I'll say, these strategic moves. And you're doing that as physical AI accelerates. You can't turn on CNBC or Bloomberg or open the Financial Times or still read print without seeing a mention of physical AI. And a lot of the credit goes to Jensen and NVIDIA. So thank you for bringing robotics from a lab to the cool world. So thank you for that. One of the interesting things about StereoLabs was they have a very passionate and dedicated developer community. Will Ouster continue to support that community?
Of course. That's actually one of the things that I noticed, and one of the things that made me confident that StereoLabs was truly in the lead was the passionate customer base that they have. They have over 10,000 customers. That's not something you don't trick anyone into buying these products. 10,000 customers doesn't happen overnight. They've actually built that over time. They have great intuition about what this robotics customer base needs. And they have things like the developer community that's incredibly active and open, by the way, active and open. You can go look and read all of the good, the bad, and the ugly. And that's the kind of thing that I look for, is a company that's not hiding behind logins or paywalls or something like that. We're building a platform, and part of a platform is focusing on the developer experience and the developer community. So now, even before we acquired StereoLabs, Ouster started a developer community in the same exact style as the StereoLabs one. We want to make sure that we have open and direct communication with the developers that are working with our hardware and increasingly working with our software development kits. StereoLabs with the Z SDK and Ouster with the Ouster SDK. These are free SDKs that we want to support thousands and thousands of customers with. And I think that's resonating just when you look at the activity on these forums.
Again, and as you said, they're public. Anybody can go through the forums. I've gone through them, and I was like, wow, okay, this is starting to make a lot of sense here. And dev communities or developer communities, if you want to use that term, are a great accelerant for a company, and you get a really good pulse of where that company is going from a product perspective. Because if developers don't want to build your product on top of it, you really don't have a business, because developers are what's driving this. And one of the big developments now that you and I are aware of, and the majority of this audience, if not this whole audience, is the rise of humanoids. Humanoids are coming fast and furious. With the acquisition of StereoLabs, does that act as a potential accelerant for Ouster's move to service that market?
Definitely. I mean, so StereoLabs already has carved out a presence in the humanoid market. They haven't announced that many customers, but if you look around at marketing announcements, and there's a lot of humanoid companies, and sometimes you'll be able to infer which products are being used in the stereo systems that most humanoid robotics uses. And so, yeah, StereoLabs has done a great job. I mean, the founders there have great intuition, great product sense, great technical acumen, and they have been at the forefront of this wave of physical AI, robotics, and humanoids in robotic gripping, industrial robotic arms that are now much more flexible than ever before and really leverage the same type of unified models that the humanoids do. So definitely like LiDAR, the types of LiDARs that Ouster sells today, the REV8s, are right at the edge of what you would put on a humanoid robot. And I think it's yet to be seen whether humanoid robotics adopt the type of incredibly high performance LiDAR that we sell, just given that they're at this threshold of the kinetic energy of the system can hurt someone. There is safety involved, but it's much lower than a car or a big industrial machine like a forklift, and the sensing needs are much shorter range. Although I say that, and then we just had a great example from the Beijing marathon, and they had a robotic half marathon, and actually first, second, and third place in the robotic half marathon used Ouster LiDARs. And it just goes to show you that once you get a robot like a humanoid moving at 20 miles an hour, 15 miles an hour, whatever they were running, all of a sudden your sensing needs go way up, both because the kinetic energy in the system is much higher and it becomes a safety thing. And also when you move faster, you have to sense much further out. And this was an outdoor environment. So all three, first, second, and third, the podium was swept by humanoids operating with Ouster REV7 LiDARs. And so anyway, the LiDARs, the point being that humanoids have not universally adopted LiDAR, but they have universally adopted stereo cameras and monocular cameras, and StereoLabs sells world-class technology and products on that front. And they actually just announced a new product, the ZX Nano, in the last quarter, which is a purpose-built low stereo baseline wrist-mounted camera that gives great view of the hands and robotic grippers that are used on all these platforms. Because it turns out more sensors, way better. You ingest all this data by a big neural network and you get better results. And that includes cameras that are dedicated to very, very short range, but highly detailed and accurate stereo vision of the grippers themselves.
Well, you're clearly positioning the company for the growth of physical AI. Do you envision a future where, if you want to say you have a hybrid deployment where, let's take a factory, for example, you have some of your humanists running StereoLabs technology, and you have the large industrial robotics running the traditional Ouster Rev LiDARs. Do you envision a potential future like that happening?
Yeah, right now I see the split where safety is involved. Typically LiDAR is involved because, again, it provides the REV8s are functionally safe devices. There's a whole industry of legacy functionally safe LiDARs that are protecting people and manufacturing floors. We're bringing that into the modern era with REV8. But safety, you can't compromise on safety. And not compromising on safety means using functionally safe hardware. There's just no way around that. And so, yes, I think that's the split I see. There will be multimodal physical AI systems on a manufacturing floor, big, powerful robots doing metal bending and pressing and welding, and AMRs, advanced manufacturing robots, automated navigating around the floor. These are big, powerful machines. And then there could be these flexible humanoid robots, and some will use LiDAR. Others may not use LiDAR. They'll definitely all use sensing of cameras or LiDAR in one way or another. And Ouster is in a really good position to provide the best suite of those products of any company on Earth. I'll also say that I think there's a decent chance that flexible, safe robotic work cells are something that use LiDAR in droves. It's possible that the industry will go towards making the factory ceiling kind of a smart, safe ceiling where there are functionally safe LiDARs looking down at all the robotic work cells and providing safety zones and monitoring as an additional layer over all of the activity going on below, so that the building itself kind of has the intelligence to trigger a machine to stop operating when a human approaches it. And so there's a potential for really flexible work cell safety powered by the next generation of LiDARs like REV8.
There's a lot of opportunity there. The one market I want to touch on we haven't touched yet is defense. You're a U.S.-based company. The Department of War has a very large multi-billion-dollar budget for automation. Do you see the defense business growing for you just because of where you're based and the ISO certifications that your company has?
Yeah, this is probably one of the topics I get asked the most about, and there's so much excitement on the retail investor side. I get a question about defense work comes up every quarter. So defense is not a monolith. There are many different applications in defense, and one of the nearest term use cases is drone-based surveying. It's one of the use cases that makes the most sense to me, because the technology works today and is fieldable today. And that's, if you're going to build a business around something, you need the technology and the product to work in the near term. And so we announced a year ago that we were the first Blue UAS certified LiDAR payload, which means that the DoD and other government agencies can use our LiDAR on these drone surveying payloads. So I think that the near-term opportunity in defense is very much in surveying payloads. There's a lot of activity in developing pseudo-autonomous or leader-follower or fully autonomous unmanned systems for the military. We happily support those efforts, and we actually have we have a long list of customers there, but it's still developing, in the same way that most physical AI applications are still developing. And the bar for these things working is incredibly high, both just like practically, this is an area where you can't make mistakes. It can't be a 1% field failure rate or error rate. You really need robust systems. And there's also the making sure that the systems are behaving in a way that we're all comfortable with. I mean, this quickly goes in a direction of like everyone just immediately thinks Terminator, and we obviously can't go and build that as a society. And so I think that the defense community is figuring out where does automation even make sense. And I've seen a lot of stuff that does make sense, actually. So we have some great customers doing troop support vehicles. That's actually probably the place I'm most bullish on, is troop support vehicles, where you have basically a robotic pack mule. Now, historically, that was like a Boston Dynamics, like literal robotic pack mule, but now that's moved to 4x4, like incredibly ruggedized 4x4 vehicles that are robotic and follow troops, and carry their luggage, carry their gear, and make them far more efficient and able to focus on their task. So all that is to say, Ouster has a bunch of defense work that we do, but I think it'll take a couple more years for it to be a business that really impacts the growth trajectory of Ouster, outside of the drone surveying work that we are in a clear kind of pole position for.
Well, it's clear that you and your customers are building the future. And Angus, putting this entire conversation together, what is the future of Ouster?
The future of Ouster is to lead the world, be the world leading platform for unified sensing and perception. I think of this, I want Ouster to be the name that when you know that you are interacting with a robotic system that is using Ouster technology, that you immediately feel comfortable. Because we've established such a track record of safety, that that this system, that whether it's a car or a humanoid or a traffic light or a drone or a small delivery vehicle delivering you a package, or a forklift if you're working in a manufacturing floor around forklifts or AMRs or robotic arms, I want Ouster to be the established brand that just gives you peace of mind because we've built the safest, most reliable systems in the world. I think there's a lot, like, it's scary. It's a world where these systems aren't safe or aren't built right is a scary world. And Ouster, I want to be the company that does it all right. And I think that'll resonate with the engineers in the audience. Like, largely our strategy at Ouster is to build things that truly work, do great engineering and not cut any corners and solve the hard problems for our customers. And a lot of that now comes down to building these incredibly safe and secure systems. So in a nutshell, great engineering is the strategy and business model of Ouster, but the vision is unified sensing and perception for all of physical AI. Some company has to do it. We want to be the company that does it and succeed because we've done it so well that you really can't not use our products because it's the safe and best way to do it.
I'll summarize this way. Ouster's building trust by doing it the right way. The future is bright, the future is autonomous, the future is Ouster. Angus, thank you so much for coming on the road to autonomy. And sir, we're not going to let 14, 15 months go by before we have you back on again.
That's a deal. This was always fun, so happy to come back.